asked. Chapter 1, Electric Charges and Fields. 2 marks questions. Question 1. Write any two differences between polar and nonpolar molecules. Answer. Polar molecules, center of positive charge and negative charge do not coincide. They produce permanent dipole moment. Nonpolar molecules, center of positive charge and negative charges coincide. They do not produce permanent dipole moment. Question 2. Define linear density of charge and mention its SI unit. Answer. It is defined as amount of charge per unit length. SI unit is cm. Question 3. State and explain Coulomb's law in electrostatics. Statement. Coulomb's law states that the electrostatic force between 2-point charges is directly proportional to product of magnitude of the two charges and inversely proportional to square of the distance between them. Question 4. Sketch the electric lines of force due to a point charge Q if I Q0 and Qn0. Answer. Question 5. State and explain Gauss' law in electrostatics. Statement. Gauss's law states that the total electric flux passing through a closed surface is equal to 1 Homburg times the charge enclosed by it. Question 6. Write Coulomb's law in vector form and explain the terms. Answer. To be written with vector equation, F heki 5 equals 1 4 pi a 0 tom q q2 r squared r ra par, and explain terms like F q and q2 r at 0 r ra. Question 7. What is electric dipole? Write the SI unit of dipole moment. Answer. It is a system of two equal and opposite charges separated by a small distance. The SI unit of electric dipole moment is cm, Coulomb meter. 3 marks questions. Question 8. Mention any 3 basic properties of electric charges. Answer. 1. Additivity property of charges. 2. Quantization property of charges. 3. Conservation property of charges. Question 9. Write 3 properties of electric field lines. Answer. 1. Electric field lines start from positive charge and end on negative charge. 2. Electric field lines never intersect each other. 3. Electric field leave or enter the charged conductor normally. 4. Electric field lines are continuous curves in a charge-free region. 5. Electric field lines never form closed loop. Question 10. Derive an expression for the electric field due to an electric dipole at a point on the axial line. Answer. To be derived using formula and steps, E equals 1/4 pi a 0, na 2 p's bar r query for axial line where P equals dipole moment. Question 11. Derive the expression for electric field at a point on the equatorial line of an electric dipole. To be derived using formula and steps, E equals 1/4 pi a 0, ta P for R for equatorial line, direction opposite to P. Question 12. Derive the expression for the electric field due to an infinitely long, uniformly charged straight conductor using Gauss' law. Answer. To be derived using cylindrical Gaussian surface, E equals Lello's bar 2. Question 13. Derive the expression for electric field due to a uniformly charged infinite plane sheet using Gauss' law. To be derived using Gaussian pillbox.